inferential control is an extension of feedback control. Okay. And what was the need of this inferential control? So this is important. Okay. So this could be also somewhat you can say some issues with the feedback control, because of which we went for inferential control. Right. So what happens here in feedback control of distillation column, that here what we are doing, this is the product, right? And we are measuring the composition using composition analyzer, right? So what happens that the measuring a composition is not easy, right? Because measuring voltage, current, etc., we have flow rate. So we have different instrument, different measuring devices. We can measure it easily, but measuring composition or the concentration of a particular chemical or particular material is not easy, right? So sometimes what happens that most composition analyzers give large delay. So they will process the data, they will process the material, and then they will give its reading, right? So most of the times composition analyzer give large delay. So there will be sufficient amount of time while giving the output, right? So if suppose some particular time, so till then feedback controller will not start, right? Until it will not give the measured information, you will not be able to compare it with the set point, and feedback controller will not be able to give the corrective action because of this delay, right? So this is the first problem with this case. Second problem is that the composition analyzer, these are having very high investment cost and maintenance cost. Very high investment and maintenance cost, right? Because measuring composition, it will have to invest a lot, and then there will be a very high maintenance cost also, right? So these are the two issues with the feedback control of distillation column. So because of this, we go for inferential control, right? So what do we do in inferential control? We do indirect measurement of the controlled variable, right? So here what we are doing for measuring the controlled variable, we are using composition analyzer. So what we do here, we will replace this composition analyzer by a indirect measurement, right? There will be a setup for indirect measurement, and that this type of control will be called as inferential control, right? Indirect measurement, or we can say secondary measurement, right? So indirect measurement or secondary measurement. Okay. So now we will use this diagram, and we will have to remove many things from here so that we can have inferential control. We'll remove all this, then we will utilize this. So in case of inferential control, we'll remove this also. In case of inferential control, what we do, we provide the reflux, this reflux, inside the distillation column, or we'll take this a little upward, then it will be a better diagram. Right. So what we are going to do, we are going to provide reflux to the trace of distillation column. Right. So here we are providing the reflux dot 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 on all trays of distillation column. Right. So in this way, we will provide reflux on the trace of distillation column. Right. Then we'll remove this also, because this is not necessary. You know that the first this is the top tray. So the second step is that we measure the temperature of these trays. We measure the temperature of these trays. Right, and there will be a temperature measuring device here. Right. So using some temperature measuring device, we can place it here in between. Can place here using some thermocouple or some device. Here we'll measure the temperature of all the trays and we will provide it to a estimator. This is the estimator. Right, and these are the, we can say, temperature transmitter, TT. These are the TT, temperature transmitters. So what we did, somebody's mic is on, we provided the reflux to the trays of distillation column inside the distillation column, and then we measured the temperature of those trays, and all the temperature data will be provided to an estimator. Right. So this estimator will, the temperature measuring information will go to the estimator. This will be an algorithm which will give us the measured composition. Right. So here we can say that this estimator will give us, this will be a function of all the temperature data, T1, T2, or we can write it in capital T. Capital T we can write. So this estimator will be a function of T1, T2 till Tn. Okay. So this estimator, based on the temperature information, this estimator gives us the measured composition of the distillate. Right. Now the feedback controller starts. Feedback. Now in this, what we had done, we measured the disturbance. We measured the distillate composition, and we replaced the composition analyzer. Now what will happen? The feedback control starts. So this will be compared with the set point value. So plus and then minus. This is the XDSP, the set point value, right? And then this information will be given to the controller. This is the feedback controller. This is the feedback controller. And feedback controller, what it does, there will be, we should have a valve here. So let's copy it. So now we have the valve, and this valve we will apply on the reflux. We'll place on reflux. So this is the reflux. This is the reflux which is recycling back into the distillation column, right? So here we are providing the reflux. This is the valve, and this is, right? So we can say that the inferential control is a modification of feedback control. In feedback control, there was some issues with the composition analyzer. So this composition analyzer was replaced by another setup, a secondary measurement or the indirect measurement of control variable. Okay. And here what we do, we provide reflux to all the trays, then the temperature of these trays will be measured, and all the temperature data will be given to an estimator. Estimator will be a function of all these temperature, which gives us these estimator. This will give us the measured composition of the distillate, right? Now we got the measured information of the output. Now we will compare this with the set point variable, and then the error will be given to the controller, and controller controls the valve, right? So this is the reflux valve, and here this is the inferential control, right? So here we are doing a secondary measurement of the control variable, right? So this was inferential control. I hope this is also clear.
Thanks for watching. Master Control. Master the future.